And now we're going to hear Dr. Jen Heldmann and John Grunsfeld summarize the human exploration findings. Uniquely, for the first time ever, human exploration was included in the statement of task for this decadal. And so they did issue some findings about aspects of the architecture and our implementation. So Jen, please go ahead.
Great, thanks, Sam. And I'll mention that John Grunsfeld and I co-chaired the Human Exploration Working Group, the HEXWIG. John is actually meeting with the NASA administrator at this very moment, so he won't be here with us today, but we have coordinated in advance. So if we go to the next slide, as Sam just mentioned, it's really important to note that considering human exploration in the context of planetary science and astrobiology was in the statement of task. And so this was something that we were required to do. And as Brett had mentioned earlier, this was really a concerted effort by a lot of people. There was the HEXWIG that John and I led with a group of Decadal survey members on it, interfacing also with the individual panels, mostly Mercury and Moon and Mars for this case. Thank you to everyone who provided open testimony and came to the open sessions, the white papers that were submitted that were relevant to these topics. And then also, as Brett mentioned, going up through the steering group is where these findings recommendations really come out. So I will be the messenger for the findings and recommendations related to human exploration. If we go to the next slide. We started out, it's chapter 19 in the Decadal survey, if you want to go look at that. The importance of the Artemis Space Camp, which we've already talked about earlier today, and how this can be enabling for science. And we want to make sure that we capitalize on this opportunity to make sure that we do decadal level planetary science, which includes lunar science. Next slide. So we start out by reminding everyone, I think this audience knows this, that human exploration is aspirational and inspirational. And the NASA's Moon to Mars plan has the promise of broad benefits to both the nation and the broader world. And we think that a robust science program is a motivating rationale for sustained human exploration. So one of the key findings from this work was that the advancement of high priority lunar science objectives should be a key requirement of the Artemis human exploration program. And anyone that works in the space industry knows that requirement, that word is not taken lightly. And so we mean requirement for sustained exploration. And in order to do this, you've seen this, we'll go into it in a little more detail. The Planetary Science Division should have and execute a strategic program to accomplish these lunar science objectives with an organizational structure that aligns responsibility, authority, and accountability. Brett mentioned that as well, and we'll dive into that some more. And so the Science Mission Directorate should have the responsibility and authority for integrating Artemis science requirements with the human exploration capabilities. Next slide. Thanks. So we recognize that there is a lot of high priority science that can be enabled by humans at the Moon and Mars. So the table on the left, this is straight out of the Decadal survey. What we did is we listed human expertise on the left, all the things that humans are really good at, map that to science objectives, so how you can use that expertise to accomplish your science, and then map that to the priority science questions, which are outlined in the Decadal survey that Brett was talking about. So you have traceability showing how the humans are so beneficial. And so we think finding number one, a crucial driver of sustained human exploration is using the ability of humans with appropriate training and mission planning to conduct and enable the highest quality decadal level science. That's where we're trying to get. And so how to do that, the recommendation, NASA should engage with the science community, happening. One, to define science goals for the human exploration programs as early as possible. And two, to ensure scientific expertise in field geology, planetary science, and astrobiology in its astronaut teams. We really wanted to emphasize the importance of astronaut crew training. And you heard from Cindy Evans earlier today that some of that's going on now. So that's underscored by what's written in the Decadal. Next slide. I'm going to put this in. We have some information about ISRU, In Situ Resource Utilization. It's the topic of an upcoming LSSW, but it's relevant for the Moon. The finding that there's a strategic plan needed to identify the measurements that are most critical to inform both the ISRU architecture options, how we will do ISRU on the surface, to ensure sustainable exploration, and the connection to decadal level science. Because I won't read all the key points, these are just verbatim out of the report, but there's a lot of overlap between science and exploration. when we're looking at ISRU. So we need to make sure that we capitalize on making the most robust measurements in both areas. Um, we talked about the possibility of an oversight structure to make sure we properly allocate resources, reserves, once they're identified, to make sure that these valuable assets are available for science and for exploration in an equitable way. And also considering the ethics of ISRU, because remembering that humans are the trustees of our planetary environments for future generations. So thank you to the folks who wrote white papers on that topic as well. Next slide. So now we'll get into the organizational structure for incorporating science into human exploration. As Brett alluded to, there's a lot of work from a lot of committee members doing deep dives into how NASA is organized to enable Artemis. So some findings, the committee believes that a systems engineering approach would be the best option to incorporate science objectives and requirements in the earliest stages of human mission planning and hardware development. The later you do this, the higher the risk that the expense will be prohibitive to actually do the science you want to do. And science can be excluded altogether when it gets too far down the track and you can't fit it in. We've seen a little bit of that happening already. Another finding from the group, the organizational structure for lunar science and exploration at the beginning of Artemis has compromised the agency's ability to ensure the highest priority science goals will be accomplished because science requirements have not been adequately provided or incorporated into the human exploration architecture. So in this case, the science return from the first few human landings in the Artemis program may not be as significant as they could be and may be minimal. So the last finding here, without an integrated coherent strategy, it'll be very difficult to accomplish decadal level planetary science. You can use human exploration to achieve lower level science goals, but to get to the high level decadal class science, you have to incorporate top level requirements into human exploration. Next slide. And there's more supporting detail for all of these in the report. These are literally cut and pasted out of the document. So you've seen this before, and Lori Glaze mentioned that PSD and SEO are working on this, so that's great. PSD should develop a strategic lunar program and using human exploration as one option in addition to the robotic missions to achieve the decadal level science goals at the moon. And NASA should have an organizational approach where the Science Mission Directorate has responsibility and authority for developing those science requirements to be integrated with human exploration. Also in the report is the recommendation to consider establishing a joint program office at the AA level to develop these program level requirements across the different directorates, the Science Mission Directorate, the Exploration Systems Development, Space Operations, Space Technology, et cetera. Those are all sort of the same organizational level, and having one joint office, one level above that might allow for more integration. John Grunsfeld spent many, many hours in the NASA headquarters library researching how Apollo was organized. And it turns out Apollo had a lot of reorgs during its existence. But down towards the end of the track, they eventually did have a joint program office. And you can see the benefits of that when you see the more science that came out in those later missions. So that's something for NASA to consider. Next slide. So you've seen a part of this. Brett showed you the left-hand side of this. And this is the rest of the org chart for Artemis, which includes STMD and the human side of things, formerly the Human Exploration Operations Mission Directorate. So the point is not for you to read every box. There are a lot of boxes. There are a lot of levels. There are a lot of arrows. There's different colored arrows. There's dashed arrows. There's solid arrows. The point that the group wanted to make with this is that there is not a solid arrow going from SMD into the human exploration side to have the authority to provide requirements. There are goals, there are objectives, and those are nice, but not sufficient. So the point of this was that there needs to be, a more concrete way to get requirements from science into the human exploration architecture, because at the end of the day, it's requirements that make things happen. Next slide. We also have a section about commercial vehicles. We've heard a lot about this today. One of the findings, commercial human spaceflight to the moon and Mars may provide unprecedented payload capacity and could have tremendous opportunities for planetary science. We may be able to lower the cost of surface access significantly And so this will put us in a new paradigm for planetary science and astrobiology investigations, technologies you can fly, and human exploration of space. So the recommendation is that NASA should develop a strategy to utilize opportunities to fly science payloads on commercial test flights and also crewed flights to the moon and Mars as these opportunities arise. And as we talked about earlier today, the SpaceX Starship is on contract through the Human Landing System to bring NASA astronauts to the lunar surface. Next slide. Yeah, so there is a lot of work that needs to go on, and some of this has been talked about today. Some of this is ongoing, some needs to be increased in scope, but we wanted to make sure we capture this in the Decadal survey so that NASA could point to this and say, yes, yay, verily, we need to do this. And this is a list of representative SMD research and development activities to enable and optimize high priority science from Artemis. So we've heard about some of these things that are ongoing and some that are ramping up. I won't read through all of the descriptions, but things like cold sampling and curation, like getting samples from the permanently shadowed regions, sample science and how we go about that and how we allocate, in situ measurements, how we actually do that, what measurements need to be made, what instruments do we need. We talked a lot about science requirements and getting science requirements in, landing site selection, science accommodation trades. If you can't bring everything, what do you bring and how do you make It's not advancing for me. Can we go to the next slide? Oh, I think this
Jen,
is
you sort of froze up there for about a minute, so whatever you said for the last 60 seconds was lost to the world.
okay, sorry,
So,
it's fine. They can read this. Yeah, you can read the slide. It's okay. And this is the last slide. International cooperation. Um, the committee and the Decadal survey felt that there are benefits to international cooperation, spreading out the cost over a large number of participants, so it's more affordable to each. Provides a wider participation of people from different countries and cultures who can participate in these space missions, and enhancing international cooperation and peaceful endeavors. These are all positive things. There also is enhanced risk with international cooperation in terms of coordination, managing schedules, potential for increased cost. There can be miscommunications of requirements, and a partner could withdraw at an inopportune time. However, given all of that, the finding is that the report is supportive of international cooperation, and NASA's continued encouragement of international participation in human missions is beneficial to enhance science return from the missions and provide a forum for constructive and peaceful interactions between countries. So we thought this was a worthwhile thing. Next slide. I think that is it. But there's obviously much more in the report itself.